Hello friends, this video on alternating currents part 20 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 19 before going ahead with part 20. So here comes the first problem. The problem says that the peak voltage of an AC supply is 300 volts. What is the RMS voltage? So that means peak voltage. What is peak voltage? We represent AC voltage as V is equal to Vm sine omega t. So here Vm is the peak voltage. Right? So this peak voltage is given as 300 volts. We have to calculate the RMS voltage. So we have found out a relationship between RMS voltage and peak voltage, that is Vrms is equal to V peak divided by root over 2. So using this we can say 300 divided by root 2 volts. So this becomes equal to 300 root 2 divided by 2. So that is equal to 150 root 2 volts. So this would be the RMS voltage. In the second part, it asks the RMS value of current in an AC circuit is given as 10 amperes. What is the peak current? That means we have to calculate the value of Im. So here also Im will be equal to root 2 into I RMS. So that is equal to 10 root 2 amperes. Right? So let us look at the next problem. It says that a coil of inductance 0.50 Henry and resistance 100 ohms is connected to a 240 volt 50 hertz AC supply. Okay. So what are the values given here? It shows that a coil of inductance this much and resistance 100 ohms is connected to an AC supply. So inductance is given as 0.50 Henry. Resistance is given as 100 ohms. It is connected to a 240 volt 50 hertz AC supply. So this is the AC supply, right? So whenever we talk about supply, whenever we talk about power supply and we talk about a discrete value of the effective value of alternating current, it means the RMS value, right? Because if I am saying it is connected to a 240 volts AC supply, we know that for AC supply the voltage keeps changing. So what is this 240 volts? It cannot be instantaneous value because that value has to be for a specific instant. It cannot be the peak value because that would be the maximum value, right? So we do not know where it says that it cannot go beyond 240 volts. So whenever you have such question which says that 240 volts AC supply, that means it is talking about the effective value of AC voltage. So that means this is your Vrms is equal to 240 volts. The frequency is given as 50 hertz. So we have to calculate the maximum current in the coil. So how do we calculate maximum current? Maximum current means I have to calculate the peak value of current, right? So we always represent peak value of current as Im, right? So the peak value would be equal to the peak value of voltage divided by the net impedance of the circuit, right? So now let us calculate the peak value of voltage. So what would be the peak value of voltage? That would be equal to root 2 into Vrms. So that is equal to root 2 into 240 volts. And what would be the net impedance? Impedance will be equal to root over R square plus Xc minus XL whole square. Now in this case there is no capacitor. So that means Xc is equal to 0. So this will be equal to root over R square plus XL square. Now what is XL? XL is omega L. So this will be omega square L square. Now what is omega? Nu is given here. So from this we can calculate the value of angular frequency, which is 2 pi nu. That is equal to 2 pi into 50, which is equal to 100 pi radian per second, right? So now we know R omega L. So we can put all those values. This will be equal to 100 square plus omega square into L square, that is 0.50 whole square, right? So therefore, the maximum current through the circuit will be equal to 240 root 2 divided by root over 100 square plus 100 pi whole square into 0.50 whole square. So on calculation, this comes out to be 1.82 amperes. So this would be the maximum current in the coil, right? Okay, so now let us look at the second part. The second part says that what is the time lag between the voltage maximum and the current maximum. So time lag between voltage maximum and current maximum. So first we will have to find out the scenario at which, or the condition under which voltage will be maximum and current will be maximum. So right now we are talking about an LR circuit because there is no capacitance, right? So we represent voltage as a sinusoidal function. Either we can represent it as a sine function or we can represent it as a cos function. So here we are representing voltage as a cos function. Why we are representing as a cos function, you will come to know very soon. If we want, we can represent it as a sine function also, but cos function will make things simple in this case. You will see it soon. So let us suppose this is my voltage. What would be my current in case of LR circuit? Because as far as resistance is concerned, voltage and current will be in phase. But inductor is concerned, the current will lag behind voltage by some angle pi by 2. So in this case, it is a combination of these two. So that means this is clear that current will lag behind voltage. But by how much, that we do not know, right? So this will be omega t minus phi, where phi is the phase angle between voltage and current, right? So now, if you look at it at t is equal to 0, what happens at t is equal to 0? When t is equal to 0, V is equal to Vm, that is the maximum voltage. Also, at t is equal to phi by omega, what happens to current? Current becomes equal to Im, because when t is equal to phi by omega, omega will cancel, phi minus phi will be 0. Cos 0 is 1. Therefore, I will be equal to Im, that is the maximum value. So if you see, if we take this cos function, we can very discreetly find out where the voltage and the current will be maximum, right? So things become simpler for us. So that means at this time, that is time t is equal to 0, voltage is maximum, and at time t is equal to phi by omega, current is maximum. So what is the time lag? So the time lag is equal to, if we call this as T1, if we call this as T2, so the time lag will be equal to T2 minus T1, which is equal to phi by omega. So this is my time lag. Now, value of omega we have already calculated in the previous slide. So we have to calculate the value of phi here, where phi is what? Phi is the phase angle. Now from impedance triangle, we know that tan phi is equal to xc minus xl divided by r. So now here there is no capacitance. So tan phi would be nothing but xl divided by r. So this was the value of tan phi. So in this case, this would be omega L divided by R. So therefore, time lag we can calculate. So this, what is this omega? We can see from the previous slide that omega comes out to be 100 pi radian per second. So this will be equal to 100 pi into 0.5 divided by R, that is 100. So tan phi comes out to be 0.5 pi. Therefore, phi is equal to tan inverse 0.5 pi, which comes out to be 57.5 degree. So we convert this degree into radians for further calculation. So it will be 57.5 into pi by 180 radians. So now to calculate time lag, we put this value of phi, that is 57.5 pi divided by 180. This divided by omega. So that means 1 by 100 pi. So this pi will get cancelled and it comes out to be 3.2 milliseconds. So this would be the time lag between voltage maximum and current maximum. So I hope you are able to understand things better now. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.